Hello everyone, my name is Kike Lomo Oluwemimo Osilo. I'm your physics instructor for the eScience laboratory today, and you'll be expecting the following learnings to take place. The first one, we are going to have electricity, which I'll be handling, and we're also going to come up with mechanics. And what are our expectations? We believe that at the end of the session, we expect students to be able to look at the diagram given and be able to make the connections either for electricity, then for mechanics, be able to interpret the diagram and be able to put it into practice and be able to get their slope, draw their graph properly. From the experiment, they should be able to explain the precautions that they take during the course of the practical session. I wish you well in your examination. I wish you success as well, and come along with us and enjoy the practical sessions for physics class.
eScience Practicals, achieving success in science subjects.
Good day, students. You are welcome to another interesting physics practical class. In today's class, we shall be taking on electricity. Electricity. To do so, we need some apparatus. The first one is your voltmeter, your resistor box, and the resistor box, we have the digital and we have the analog. But for this session, we are going to be using the digital resistor box. We need some connecting wires. You need your key. You need your battery. Join me as we go on to explore the world of electricity. Here are the procedure. The first step is to connect your voltmeter, and on your voltmeter, for this particular one we are using, has two readings. We have the one that reads from 0 to 5 volts and the one that reads from 0 to 15 volts. If you are connecting your wire to this other side, that means I'm using the one for 0 to 5 volts. And if I connect it to this side, that means I'm using the one for 0 to 15 volts. But for this practical class, we need 0 to 5 volts. To do so, I'm going to connect it to the 5 volts, one end of the connecting wire, and you have to ensure tight connection. That is one of the precautions you need to take cognizance of. Okay, so we connect the other end of the voltmeter to the resistor box. While doing that, ensure tight connection. Okay, having done that, let's connect the other end of the voltmeter to the other end of the resistor box. Now there is a shunt, as you can see in the diagram. From the shunt, you connect the key, and in doing so, use your masking tape to hold it down. And how do you get the shunt? You just cut a portion out of the wire that is connected to the voltmeter and the resistor box. You do this to confirm the connectivity. And the other end, you connect it to the other end of the key. The other end from the resistor box, you connect it to the key. And remember to leave your key open so that it does not run down your battery. Let's move to the other side. You also connect it to a shunt and use your tie to hold it down together. There, we have our voltmeter connected to the resistor box. Then we move on to the other end, which is where we have the battery. Now I'm joining these two wires together. We are supposed to have this wire connected to the end of the battery. But since I already have that, so that I'm using 3-volt battery, so I connected 2 together to give you 3 voltage. So having that, you connect this one, the connection is still the same. Then I'll connect the other end of the key. So let me quickly go over the connection for you again. You connect one end of the voltmeter to the resistor box. You make a shunt on the wire that is connected to the resistor box to the from the voltmeter to the resistor box. You make a shunt and connect it to the battery, to one end of the battery. Then the other end of the voltmeter, you connect it to the other side of the voltmeter. From the voltmeter, you also make a shunt to connect it to the key and leave your key open, while the other end of the key is connected to the positive side of the battery. Having done that, the first thing we are asked to do is we should close the key and get our readings for V naught. Having done that, you take your readings for V naught. And my readings on V naught, we are now going over to the readings. For you to get your readings, you need to create your table. You need to get your table. So for my first reading for V naught, I have 0.35 volts. Now, let us make a table. This table is very, very important in any physics practical session, because the composite table carries a larger portion of the physics practical, especially for West African Senior Certificate Examination. You'll be given 3 practicals. You will perform 2 out of the 3, and each one of the practical carries 25 marks. Out of the 25 marks, the composite table carries up to 12 or 11 marks. That is why we have to be very, very careful when we are plotting, when we are writing our composite table. You write the values and you write the units, and you don't cut your composite table into 2. Not that you have written halfway, then you cut it and complete the other one. You make sure it is all the values that you have on the composite table. So we have the serial number, which is the first, second, third, up to the 5th repetition. Now the first one is the resistance, and its unit is the ohms. And the second one is the volts, and you slash it. So for the first reading, which is 1 ohm, let's see what happens. Remember, we have taken the V naught, then you remove the key. You remember we are using the digital resistor box. So what do? You turn the knob to 1. Then you close back the key and check your readings from the voltmeter. So what do we have? We have 1.40. And we are also supposed to have the inverse. So we have inverse of the resistance, then the same thing with the voltage. So for you to get the inverse, you have to divide each value with 1. So if we have 1 divided by 1.0, we are going to get, and don't forget that for your calculated values, it must not be anything less than 3 digits. So for the inverse of 1 ohm, we have this. And the inverse of 1.40, we have 0.714. Now let's take the second reading. Don't forget to always remove your key so that it does not run down your battery. That is also, I've given you 2 precautions now. The first one, you must ensure tight connections. Then the second one, you must make sure that you always leave your key open. So having done that, you return your knob back to 0. Okay, so we are going to take the second readings now, which says 2 ohms. For 2 ohms, you return the knob to 2 and return back the key. Then you come to your voltmeter to take the readings. So for this, we have 1.65. Then we now take the inverse of 2 ohms, which gives us 0.500. And the inverse of 1.65, we have 0.606. So we are going to do for the 3rd ohm, the 4th ohm, 5th and the 6th, as you can see on the board. Having taken our readings, the next instruction says we should plot a graph of V inverse against R inverse. A graph of V inverse on the vertical axis and R inverse on the horizontal axis. Let's have the arrowhead and you label your graph. So for the vertical axis, we have V inverse. Don't forget to put the units. And we have R inverse and put the units. Now, for you to plot the table on the graph, you don't bring the values directly from your table to the graph. You have to take cognizance of the first value and the last value. And we don't use figures such as 3, 5, 7. You can use 2, 4, 6, 0, or you can use 5, 10, 15, and so on. So for this particular one, we have the highest value on the R inverse to be 1.000 and the lowest value to be 0.167, as you can see from our table. And for the V inverse, we have 0.714 as the highest value and we have 0.465 as the lowest value. So the next step we are going into now is plotting of the graph. And we are instructed to plot the V inverse on the vertical axis and the R inverse on the horizontal axis. To do that, you check the values, the highest value and the lowest value for both axes. Then you'll be able to divide it, okay, for how many units are you going to use per centimeter. You get that. So for this, we are going to use 0, since we have our highest value as 1 and the lowest value as 0.167. So we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Since our highest value is 0.716. And on the horizontal axis, we have 0.2, 0.4, 0.6, 0.8, 1.0, 1.2. Now, you don't bring the values directly and put it on the graph board. For the first value on the R inverse, we have 1.00, which is what we have here. And on the vertical axis, we have 0.714. So, if this is 0.7, remember what each unit represents. So, our 0.171 should be somewhere here. Then you trace it down to where we have 1.0. So, you use a plus sign so that it can synchronize with the lines on the graph. You don't use a cross sign and you don't use a dot, so that you are sure of where the line is or where your point is. That is for the first value. Now let's take a look at the second value. The second value, we have 0.500 and 0.600. So our 0.5 on the vertical axis is here and our 0.6 is somewhere here. So you trace it out and put a plus sign. And as you can see, we have gotten 45 values on the graph. The next instruction is for you to get your line of best fit. And when you are getting your line of best fit, that means a value must be up and you must also have a value down. You now pick the one, either it is 2 or 3 that the line must cut across. And in this particular exercise, we are told to also get the line of what? To get our slope and also the intercept. So as you can see on the graph, now let us pick the line of best fit. For us to do that, we can see that the last value is out and there's another value up. So it picks the 3 value in between. And for you now to now get your intercepts, they specifically told us on the vertical axis. That is where that your straight line cuts across on the vertical axis. And we can see it. You also have to note it. You put capital letter I on where it cuts across on the vertical axis, which we have seen. So you put your capital letter I on that. That is your intercept. So having done that, they told us to also look for the what? The slope. And your slope must be a large right angle triangle. For you to get your slope, which is a large right angle triangle, you pick on the line that crosses across to the intercepts. You make a large right angle triangle. Then with a dotted mark, you trace it down to the horizontal and you trace the other one to the vertical. So you can have your triangle as what? A, B, C. And your slope will now be change in V inverse all over change in R inverse. You write the value. So we can now have your V inverse will now be BC all over AC. We have A, B, C. So what is the value for B? You pick it on the vertical axis and you pick your value for C. And the same thing on the horizontal axis. Your value must tally with what you have as it is on your graph, because that is what we trace. If you have given us a particular value and it does not tally with what we check on the graph, you have missed your mark for that slope. So you don't pick somebody else's slope against your own graph, because if you have written a particular value, we are going to check it and write it out. So having done that, you have gotten your slope. You divide it, you get your values as you have seen on the screen. Now that we have gotten our slope, because in your part B question of this practical, you'll be using your slope to solve some questions as being asked. Let's go to the precaution like I mentioned during the course of the practical. The first precaution is it must be in the past tense, because that was the precaution you took, not in the future tense. You will not say, I will. The precaution proper is going to be, I ensured tight connections. I ensured tight connection. The second one must be, I ensured I removed the key. I leave my key open when I am not taking the readings. And we know why we are doing that, so that it will not run down our battery. You must leave the key open when you are not taking your readings. Another precaution could be, you read the voltmeter vertically to avoid error due to parallax. I avoided error due to parallax when reading the voltmeter. Those are the precautions. You will be asked to state only 2 precautions. And you can choose any of the 3 precautions to use. Thank you. See you in the next class.